9.5. 9.5 is on comparing interest and rental and loan cost. Boys, thanks this time. I'm now teaching. You're either actively listening or actively taking notes. Thanks. Here we go. What are you doing in 9.5? So you learned simple interest. You learned a bit about compound interest. Now it's about how do you find the better loan? How do you determine which amount of money, whether you're renting or you're borrowing money or you're investing, which one is going to give you bang for buck, essentially. One of the things that we need to understand is that when you borrow or invest money, even though it's the same amount of money at this particular point, it is always valued less in the future. Hey boys, like I said, if you're not interested, I'm happy for you to leave. You don't need to be in my class. But if you're talking while I'm explaining things, especially when we're starting to do these points, I find it highly disrespectful. Yeah? What do I mean by the same amount is valued less in the future? You probably already understand the idea of inflation and changes in the economy. $5 can get you something like, say, a sandwich today, but that same amount of $5 will not get you the same amount in 20 years. Okay, so that concept we understand, and there's a lot of reasons for that. It could be the cost of ingredients changes. Why do those change? Because economic changes. Whether growing those becomes easier, harder. Is there more demand? If there's more demand, they might raise the price. They might lower the price to help with the demand. Because if they keep it cheap, then if everyone keeps buying it, they run out of resources to keep providing. So they increase the price to see how many people are willing to still buy it. That's what supply and demand does, right? But as you increase those prices over time, the $5 that what used to get you your sandwich with your bread, lettuce, and ham, it can't be the same in 20 years. So this is why when you borrow money or you invest money, you get this interest. And that interest is to accommodate or compensate for the changes in the economy. Okay, that's the idea. Which means that if you account for that, even though they say they're giving you a salary increase, let's say take the teacher's salary thing where they've increased over the next 4 years, there's a difference between 3 years versus 4 years. Because each year there is an inflation of average about 2 to 3%. So if you say you increase the percentage to, currently they said 32% over 4 years versus 28% over 3 years, you're like, 32 is higher than 28. But if you think about it, it's 32 over 4. If you divide that versus 28 divided by 3, it's a lot better to get the 28 by 3 than it is because you have to account for all the other changes in each year. Okay, so that's why it sounds like it's a good deal when they say 32% and they take that your income now increases over the next 4 years. It doesn't take into account of all the changes that could happen. That's why when people ask for a compensation, it needs to be above the inflation rate and what we expect could change in the economy. Okay, that's the idea. So keeping that in mind, that's what banks do as well. So here's an example one. Say you got an $80,000 loan. So you're borrowing $80,000 and it's taken over 15 years, meaning that you're going to borrow it for 15 years before you pay it back. And interest is charged at 4% per annum. So every year, to account for inflation and all the other things, they're charging you 4% plus profit. Okay, so they get profit from that too. Otherwise, they're just giving free money. So interest is charged at 4% per annum. And it is to be paid off with monthly repayments. So every month you have to pay $591.75. Now to clarify, at foundation level, you do not need to know how to get that amount. Okay, so this amount here, this is what separates general maths and then foundation. In general maths, you do have a program called Finance Solve, and it allows you to find out the repayments. These repayments are not random. It actually follows a formula. For those who are interested in the formula, which is the university formula, it's at the very bottom of the page. Okay, so when you have interest, so compound interest, remember I showed you it compounds over time and it looks like that. The problem is that that model assumes that you don't take money out or put money in. So it assumes that you just put the money there and you just let it grow over time. That's your compound interest. The problem is that if you decide to put in more money, that changes the fluctuation each day and each month. That formula that you had from compound interest doesn't account for it. This one does. Okay, and where this comes from, there's a bit of calculus involved in it to get to this formula, which I would not be explaining because even I forget the steps on how to get to the formula. Okay, but if you're interested, that's where the formula is coming from. So in your CAS calculators, those who do finance solve in general maths, that's what it's doing to find out your monthly repayments. For foundation students, you'll always be given how much it's going to be repaid each month. Okay, that's always going to be the basis because you don't have the formula to figure it out and you don't have a CAS calculator to do it. Okay, so that's the main difference. But everything else is still the same. You still have how much did you borrow, how many years are you borrowing it for, and at what interest rate per year is that happening. Notice here it says interest charged monthly. That's a key line. Interest is charged monthly. It means that every month they will charge, a percentage of the 4%. So they do 4% every year in total, but every month, so 12 times a year, they're going to charge you on that. So they don't charge you once a year, they charge you 12 times a year. And you remember how I mentioned in compound interest, the more times they charge you within a year, the more money they make from you. Okay? Here we go. So how do we calculate this? Determine the amount of interest paid after 15 years. Well, here we go. We've got $80,000 you borrowed today. You make monthly repayments of $591.75. This already includes the 4% per annum already. This is not separate from it. So after 15 years, if you made monthly repayments of $591.75, I've guided you through my notes here. How much money or how much have you paid after 15 years? So to work this out, if every month you pay $591.75, beautiful. So first you got to figure out if it's happening every month, this is how much you're paying every month. Well, there's 12 months in a year. So since there's 12 months in a year, but you're doing it for 15 years, well, 15 years times 12 months will tell you how many months in total that you're going to be paying $591.75. In a way, that's how your mortgage loans will work. So if you get a house and you borrow money and they talk about mortgage, well, each month you're paying a certain amount. Usually it's not $591. Usually it's about maybe $1,600 to about $5,000, depending on how much you borrow. So let's work it out. What's 15 times 12? 176. All right, 15 times 12. Why does it say 180? 180 months. So we got 180 of these months. Therefore, how much do you pay in total? It's 180 months, and every month you pay $591.75. So we do 180 times 591. So 180 times 591.75. And you get $106,515. So $106,515 is how much you would have paid after 15 years. Okay, that's about $100K. So about $100K after 15 years. But you borrowed $80,000 initially. So remember, you borrowed $80,000 initially. So the amount that you pay extra would be $106,515. Take away $80,000 will tell you what's left over. Now, I already filled it out for you. That's $26,515. What does that mean? That means after 15 years, you paid an extra in interest, which compensates over the 15 years for the inflation economy changes of $26,515. Okay? That's the idea. Now, this is a very hypothetical situation. Not so much so true, but it's a hypothetical situation that you borrowed $80,000 and you paid about, what's that? 80 over 25. It's maybe almost a third of it, or less than a third. Yeah. You paid about 1/3 of it into interest. Okay, so the sooner you pay off your interest, the better. The more money you put in, on top of your 59175, the less interest you pay over time. That's the idea. Okay, so that's example 1. It's very, very logical there. What it basically means you need to know how to do the conversions between months, years, and then calculate what's the difference between total money versus interest. So what you borrowed, total interest. So this is the total amount you paid, total paid. This is total borrowed. And then this is leftover, which is the interest or extra. Okay. So that's one part of 9.5. 9.5 is to actually work out how much interest you would pay over time. Once you can work out how much interest you paid over time, then you can compare which one's a better loan to borrow. So flip over the page when you're ready, flip over the page, and we're going to look at some loans that we can do some comparisons with. Here we go. 3, 2, 1. Last example for today. Example 2. So a couple have 2 rental options. So this is now a renting option. Doesn't have to be rent. Could be borrowing money. In this case, it's rent. Option 1, you can either rent for $450 every week, or you can get rent charge every 3 months, which is quarterly, at $5,950. So which one do you choose? This one's a sort of an easy starting off question. So here, how do you actually compare them? You can't compare them because one measures every 3 months, whilst the other one is weekly. So you either make them all the same units, they either have to be per week or per 3 months, and that's how you can compare them. But there is a caveat. You got to be careful. Reason why you got to be careful is every 3 months, and this is one of the things that students get confused between. Anyone know how many weeks are there in a year? There are 52 weeks in a year. But then how many weeks are there in a month? 4. But then there's 4 weeks in a year, in a month, but then there are 12 months in a year. 4 times 12 gives you 48.
I was right, yes.
You see that problem? We say there's 52 weeks in a year. Then when I ask you how many weeks are there in a month, you'd say 4. And then 4 times 12 months in a year gets you 48 weeks. So which one's the correct one? Do we use 48 or do we use 52? Because it matters if you look for 3 months and you want to convert it to weeks, you could do 4 times 3, which is 12 weeks. That's a problem. So the standardized amount is actually 52, not 4 weeks in a month. Why? Because 4 weeks in a month is an approximation. That's why you have leap years. Yeah, so that's why it happens you're missing that extra 4. That's why every 4 years, that's why you're missing that extra 4 weeks. So don't do the 4 times 12 and then convert it into, 4 times 3 to get to 12 weeks. You have to use 52 weeks, which is for 1 year. And then to get 3 months, you divide quarterly, because it's 3 months is every quarter. So you do a quarter of 52. That's equivalent to then 3 months. Okay, so just be careful with that one, that conversion. Convert this 52 into quarterly, not the other way. Don't do 3 months into weeks, because then you'll be wrong. Does that make sense? Okay, so I was trying to highlight one of the common misconceptions, 52 weeks versus 48 weeks. Doesn't make sense then. So option 1, if you rent it for a year at $450 per week, well, we know 450. There's 52 weeks in a year, so 52 times 450 is then $23,400. Versus option 2, every 3 months. Since we know that there are 12 months in a year, then that's 4 of those quarterlies. 4 times 5,950 will tell us in 1 year. So what I'm doing here is I'm making it both a year. But if you want to do it for weeklies, then you have to be careful with those numbers there. Okay? But 52 is your gold standard. 52 is your gold standard. Here we go. 4 times 5,950. What does that give you? $23,800. So now that you can compare it from a year-to-year basis, this one was $23,400. This one's $23,800. So therefore, which option is better? 1. But it's only possible because you have to compare by the same units. So if you did it weekly, just be careful with 52 weeks. We usually do in years. If you do it per year, it's usually a lot better unit to try to measure. Okay, so every conversion you do, bring it back to years. All right, here we go. Last example. So this one is a bit more involved, but same idea. You're doing a comparison. Which one is a better one? James wants to see if he can afford to purchase a property or if he will decide to rent. Should we rent or should we buy a house? People say that buying a house has capital growth and you can sell it and you make profit from it. What they don't take into consideration is that they got to pay stamp duty and all the other fees if they rent out. There's a lot of extra fees. So the question is, how much more profit do you actually make after all of those? There's maintenance as well, depending on what you buy. If you buy an apartment, there's body corporate fees that is involved each year. Versus rent. Rent, you might find it harder to save, you'll find it easier to save compared to mortgages because most of your pay goes to mortgage. So you can save a bit. So in the same duration, say in the next 30 years, which one's usually better? It's always a debate. It depends on what you do with your money. If you invest your money while you're renting, that's a good option. If you then buy, remodel, and then sell, and obviously invest in property investments is also good too. So there is no right or wrong, but in this particular question, where we're sort of modeling it, so there's one answer. Yeah. So Jay needs to borrow $680,000 if he wants to buy a house on top of his deposit to purchase a property at 3.75% per annum over 30 years. He will need to make weekly repayments of $726.26. Sounds confusing, but you do have to get used to that language there. Versus, he rents, it will cost him $495 per week. The question is, which one is a better option? Now, to guide you along which one's better, they've given you sub-questions. Calculate the difference in weekly cost for option 1 and option 2. So here we go. Weekly, we know option 2 will cost $495 per week. So $495 for option 2. That's per week. How do you work out the weekly cost for option 1? What's the weekly cost for option 1?
Weekly repayment times 3 points.
Not bad. It was actually just 726.26 because that's your weekly repayments. Usually your repayments already accommodate for the interest. Yeah. So that's why in my first page I wrote over here, it already includes the interest. So that's a good point that you picked up because that's what a lot of students get confused too. So your repayments normally accommodate for the percentage in it. Yeah. So in this case here, weekly amount, fill this in. $726.26. What's the difference? 726.26. Take away 495. And that's how I got 231.26. So the difference between them, 726.26, take away 495, gives me that answer. So obviously on a weekly basis, one is more expensive than the other. So option 1, thanks boys. Option 1 is $231.26 more expensive weekly. Part B. Calculate how much more James would pay if he took out the loan over 30 years compared to paying rent over 30 years. So this one we only calculated per week. What happens over 30 years? How would you know the difference between them? So same thing again. We can then multiply 231.26 by for each year. What do I multiply it by? 52. Your golden number for a year. So weeks to years is 52. And there's only 12 months in a year. Yeah, so weeks to years is 52. Months to years is 12. Okay, don't convert it the other way. And then multiply it by, very good, because that's only for 1 year and we need 30 years, so times by 30 for the whole duration. So here we go. You should end up with $360,000 and 765. Let's see if it's true. We go 52 times 726.26 times 30. Wait, what's going on? Did I multiply the wrong one? Oh, difference weekly. Sorry. Weekly difference. Times 52 times 30. So this is this is after 30 years. That's the difference. If every week you are $231.26 difference, this is how much different it is over 30 years. So after 30 years, you're about 350K difference. So in 30 years time, you're about 360K difference, which is quite a bit. Does anyone know what the average superannuation when people retire at the moment currently is? No, that's what we'd like it to be. No. So you retire about 65. You guys might be a bit later by your time, but do you know what the average in your super? It's about there. 500 to 600,000 if you've been depositing enough. If you don't, it's actually between 300,000 to about 500,000, somewhere there. You can put more. Yeah. So I put in more. So I do what they call salary sacrifice. So when I get my pay, instead of it going directly to me first, I tell the department to take a portion of it. So $400. I get them to take $400 and put it into my super. The reason why I do that is because then I get taxed less, which we'll talk about in the next session. Whereas if it goes to me, I mean, you could still get it taxed during your tax time, but you just have to declare it. So instead of it, I just get it done first, and that way I don't have to declare it. Yes, that's right. So it's an investment that I'm doing, and it's only into my super. But a typical amount that most Aussies in general, in Melbourne anyway, I don't know about across, on average, it's between 300 to 500,000. And if you think about that difference over 30 years, that's quite a bit. That's an amount that could have been part of your super. So renting seems like, what are you going to do with that 360,000 difference? Would you have invested in those 30 years, or would you have wasted that amount? And that's the planning that you can do, maybe even from now, like I'm saying. So from 20 to 50, you got 30 years that you can plan on how you can use that money. If you're renting, what are you going to do with that money? Are you going to make more money from it? Are you investing it somewhere to grow? Or are you just utilizing it? Okay, so that's where the idea comes about financial maths. Thinking about what you're going to do with your money afterwards. But yes, 300, 500K at the moment. If you're just working and using and just not putting extra, you can expect about 300 to 500,000 in the course of your work time. With my projection, if I'm putting an extra $400, apparently I can increase it to close to $1 million. So obviously, if you put more, you can expect more. Yeah. Remember, time is on your side. The longer you do this, the better for you. So had I known more about this, I probably would have done it as soon as I started working. I only did it when I was late in my 30s. If you do it earlier, probably better investment. All right, next one, C. Which is better? Any other things to consider? So it seems to me, better to rent since it's cheaper. But why would people even buy a house if renting is cheaper? Here's the key difference. I'm just going to finish off the session on this point. There is no right or wrong when it comes to renting or buying a house. If you buy a house or property, you're growing what we call equity. Okay, so the house holds value. That's called equity over time. If you're renting, then you're growing savings. Okay, so you actually have cash. So the difference between the two is just what are you more likely to grow? Are you good at growing your savings, so cash in hand, making cash flow? Or are you better at growing equity, which is having properties and not necessarily cash in hand? So none of these two, not one is better than the other. It's just better how you're going to manage your money and time. Okay? That's 9.5. Next lesson, we're going to talk about tax. So that'll be an interesting one to get you a bit more familiar with it. But that's it for financial maths today. It's just about comparisons.